Try to keep that straight as we go through these. We're going to start with the arithmetic sequences. And arithmetics start with what's called a common difference. So there's this new variable that's going to show up. It's a d, okay? A common difference is just some constant number that you are adding or subtracting to your sequence, okay? So if you look here, 10 to 15 to 20 to 25 to 30, you have a common difference of what? 5, right? We would add 5 each time. So my common difference here is 5, okay? Now, a lot of times people struggle with how to figure out that number. Your best bet is to take the second term minus the first term, okay? If I take 10 and I subtract, if I take 15 and I subtract 10, I get 5. That's my common difference, okay? Don't do the first one minus the second one because that's -5. We're not adding -5 each time, right? So take the second term, subtract the first term, and you'll see your common difference. So look here. Is this arithmetic? Am I adding the same thing? Is there a common difference all the way through? Yeah, what is it? Yeah, we would say, yes, this is arithmetic because we are doing +3 every time. Okay, look at B. Is that an arithmetic sequence? No. What are you doing?
You're adding by odds, but like more.
Oh, that you are adding the next odd number, +3 + 5.
But it's also like to the square.
It's also, yes, it's the perfect squares, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. You're not adding a constant. So is this arithmetic? The answer there would be no, okay? So there's formulas that go with just the arithmetic version of these. They're going to look very similar to what we've done already. The recursive formula really doesn't look any different, okay? You take your first term, you take a sub n equals a sub n minus 1, and then the only difference now is it's going to be plus whatever our common difference is, okay? So when we're working with an arithmetic sequence where we're adding the same thing every time, the recursive formula is going to add the common difference at the end. Okay, the explicit formula looks a little bit different. Here's what you do with this one. And you've probably seen this before. You've done this in Algebra 1, is my guess. But you take your a sub n, you set that equal to your first term, right? A sub 1 is your first term. This n represents your term number. So like if I want the 5th term, I'd be plugging what in there? A 5, okay? And then the D is your common difference. Okay, just like the D right here is also your common difference. Okay, so we're going to take a look at a couple sequences and we're going to write both types of formulas just to see how this plays out. So if you look at example number 2 here, what is your common difference? How am I getting to the next term each time? 3, right? We're adding 3 to each one. Okay, so if I'm going to write a recursive formula, it's got to be a sub 1 equals what? 7, right? Your first term is 7, so a sub 1 equals 7. A sub n equals a sub n minus 1. Remember, nothing changes there. It's always going to look like that when you write your recursive. What are we doing from there? +3. Plus your common difference. Our common difference is 3, so it's going to be +3. Okay, so that's the recursive formula. The explicit formula, if we plug it into this, okay, it's going to be a sub n equals what? 7, our first term, plus, it's just the formula. Whenever they ask for the formula, n stays put. So don't try to plug a number in for n right now. N is our unknown, it's our variable, it's our placeholder. Times what? 3. The common difference, which is 3. Okay, Now this is not the prettiest. So if we just distribute that, we get a sub n equals 7 plus 3n minus 3. Simplify that one step further. You get 3n plus or minus? Plus 4. 7 minus 3. So this is your explicit formula. Okay, lay it out as best you can.
I have a question for like example 1. Like for part B, would that be geometric? Because would that be multiplication?
It is multiplication. You're not multiplying by a constant. So yeah, it's a little different than a geometric sequence, right? You are multiplying, but with geometric sequences, you need to multiply by a constant. Yeah, so we'll get into that in the next lesson. I'll explain that more. Okay, example 3. So you have these 4 numbers, 213, 201, bless you, 189, 177. It says write the recursive formula. You try that, okay? Write your recursive, write your explicit, see what you come up with it, and then I will come check it out. All right, how'd we do? What'd you get for a recursive formula? What comes first? A sub 1 equals 213, right? And then a sub n equals a sub n minus 1. Make sure that n minus 1 drops low enough or is small enough that you realize I'm not actually subtracting 1 from my equation, right? It's saying the term before this term, okay? So a sub n minus 1. And then what are you doing to that? Minus 12. Okay, so that's your recursive. What'd you get for explicit? So in the end, negative 12n plus 225. Let me show you how we get there. So it's the first term, right? That's your a sub 1, if you're up here. 213 is your first term. Plus, that will always be plus. Don't ever change that to minus, even though your common difference is minus. And then it's n minus 1. And then your common difference is basically saying 201, the second term, minus the first term. That's a negative 12. Okay, now distribute that. So 213 minus 12n plus 12. So a sub n is 213. That's not the way I want to write that. Negative 12n plus 225. Okay. So then the question is, letter C, what's the 25th term of the sequence? Can you tell me which formula makes more sense?
Explicit.
The explicit. When you're asked to find the nth term, any term number of a sequence, explicit makes, way more sense, okay? So you're going to plug a 25 into the explicit wherever you see n. So we would say a sub 25 equals negative 12 times 25 plus 225. Please feel free to use your calculator every single time on these. What do you get? Oops. So your 25th term is? What is it? Negative 75. Any questions on that? Okay. The next thing that we're going to talk about, the last thing for this first one, is called an arithmetic mean. And if you think about Algebra 1, we did mean, median, and mode. Do you remember what those all are? What's a mean? Mean is the average. Remember what the median is? The middle number. And then what's the mode? The one that shows up the most, right? The mode shows up the most often. So we're talking arithmetic mean, which is the average. So if I give you two numbers and I say find the arithmetic mean, you're finding the average. So you add them together, right? You take the sum of the two numbers and you divide by 2. That should be well ingrained in the brain, hopefully, at this point. So let's look at this first one. Find the missing term of the sequence. You have 84 and 110. How do you find the mean? $84 plus 110, and then divide by 2. Be careful when you plug that into your calculator, because sometimes your calculator wants to do 84 plus 110 divided by 2. You want to do 84 plus 110 divided by 2. So maybe just hit enter after your 84 plus 110 and then divide by 2, or put parentheses around it, anything to avoid a silly little oopsie there. What'd you get? 97. Okay, now look at B. You have 3 numbers in between there. God bless you. What can you do to find those 3 numbers?
You do like 48 plus 12 divided by 5.
Not divided by 5, but I like the way you're thinking. One of these numbers, oh, go ahead, Noah.
I don't think this is the right way to do it. Could you do like 48 minus 12 plus 36 divided by 4 plus 12 plus
Okay, that would be a process, but I think you would work out that way, if I heard everything correctly. So yes, but I have an easier way for you.
Does the 2 change if like there's multiple?
No. I mean, the way Noah explained it, it would, but I don't recommend that you go through all that work. There's a quick way. Do you think you can maybe find this number for me right now? If you take 12 and 48, this one in the middle is your average. It's your middle, right? So 12 plus 48 divided by 2 is going to be 60 divided by 2, or 30. Okay? Do you see a way to find this guy now? Right. So now you can find the arithmetic mean of 12 and 30. So now if we go 12 plus 30 divided by 2, that's 42 divided by 2 is 21. And now do the same thing over here. 30 plus 48 divided by 2. So you get 78 divided by 2, which is 39. Okay? So if there's multiple blanks like that, as long as it's a number that you're actually finding the true middle of, right? Because if there were 4 blanks here, that wouldn't work. But because there's 3 blanks and we can find that one in the middle, okay, you find the average there, and then you use that new average to find your other 2 averages. Does that make sense? Tell me yes or no if it doesn't. Yes? You're good there? Okay. Okay.